So as you've seen in the last video, it's pretty simple to set up a very, simple Houdini 18 RBD setup, but it used to be much more complicated than that. And let's quickly build our little setup here that we have, even though we're actually not using constraints because that's a bigger topic. But let's see how we would build the same setup the old way. And the reason this is important, and I decided to put it in, even though during the course we will rely on the DOP SOP because it's so much easier to work with and simplifies the already very complex topic of RBDs. I still want to make sure that you see the manual way because they're out there. There's so many tutorials that use the old way, of course, because the new one is pretty new, that it's very important at least to show it. So of course what we need is a DOP network. So much it's straightforward. And then you need the solver. So what's a solver? If you type in RBD solver, you actually get one. Okay, cool. Is that the one? No, it's actually not. Because before side effects used the bullet solver, it had its own system, and that is the RBD solver. So this one would be the complete wrong decision. Now, if we know that, maybe there is a bullet solver, and yeah, it is. And on top of that, and this is actually basically the one we're using, but there's actually a third one, and then now it becomes confusing. When you type in rigid body solver, then you find another solver with that name. So what's going on here? Basically, this is the old one, the gray one, the RBD solver. It's not really used anymore. And then you have the bullet solver based on the library we just saw, and this is what we used most of the time. And then there's a rigid body solver that basically has both included in one. And whenever you work in the DOP network directly, I would always recommend this, which is set to bullet by default, but it's just a little bit easier to work with it because the inputs are a bit more logical. And it kind of follows more the standard DOP logic. So keep that in mind, use the rigid body solver usually. Then you need an object, and here it becomes complicated again. You have an RBD object, makes sense, but if you look further for RBD object, you will also find an RBD fractured object. And this is kind of the second version of this. And the idea here is that you have, and it was, of course, when we talk about RBDs, what we mainly talk about is destruction. And fractured already tells you what this is about. Very similar to the vellum weld idea is you pre-break an object, then you glue it back together, and then you break it and then simulate that. And this is what you need an RBD, or needed. We don't really use the RBD fractured object anymore, but to make this work, you used to have this second version. Now, when you now type RBD object again, you will find a third one, and that is the RBD packed object. And this is actually the most important one. This is something we will talk about in the next video. Very important. You can actually pack your geometry, or you can work with your RBD simulations in a packed form. And the reason for that is since one piece of object doesn't deform anyway, because that's the definition of a rigid body simulation, then you can actually simulate it as one point, because all it has is now a position in space and a rotation and speed and all that. But basically, you could calculate all those things as if it was one big object and is represented in one point. It will make a bit more sense later on, but just keep that in mind that you can simulate stuff as a packed object, and this is actually the standard. The RBD bullet solver, so the SOP solver, actually does that internally. If you're interested, you can always go in and try to understand what's going on, and you will find there is a switch up here. Yes, it's called housekeeping, and here it basically finds out whether you have a packed object that comes in or not, and it will then pack it anyway. So the new system internally always uses pack geometry. We'll talk about this further later on. So this is then the object we use nowadays. You can, by the way, combine the two. That's totally fine, but just keep in mind they're different ones. And then you can, of course, use a gravity and all that, and a ground plane and a static object. All of this is pretty normal as before. One thing to keep in mind when it comes to collisions, though, and we will talk about this later as well, since bullet is its own library that does not come from side effects, the whole system actually doesn't understand SDFs. It doesn't think in any kind of volumes, and this is just something you have to keep in mind. That's the reason in the static object that you can, under collision, actually change between RBD solver, which is the reason we use that in everything else. But in RBDs, we actually use bullet data because it just gives you a hint that bullet doesn't understand anything else, which includes volumes. So that's just something to keep in mind. And then another one that is a bit confusing and complicated is how to get constraints into this. And for this, you actually need a separate node called constraint network. This is the node that takes care of the constraints, so it's not automatically built in actually. And then on top, you need to create every constraint that you would possibly need to use in your simulation. So imagine you would have to build the Vellum setup from scratch, and you would have to install in your setup every single constraint you might want to use. And this is basically how it goes here. We will talk about this much later on. In the bonus lesson, I think we will talk a little bit about this manual approach. But until then, I will, of course, not use this manual approach because it overcomplicates things unnecessarily. But you will see that in a lot of tutorials, and I just wanted to make sure that you understand the core setup. So again, here comes your, usually in the first input in the RBD packed object, this is where your geometry comes in. And then you have to tell the constraint network that from the second input, for example, come your constraints, and then we can actually connect it the same way. And the same is true for the box, because this is then also, it uses a static object. So we have to use the OP input path, and I put it into the last input. So it's the 3, because it's the fourth input. And again, it will use internally the bullet data, which I can visualize. There it is. It will not use the RBD solver or any kind of SDF, but only what bullet gives you. So this is basically the setup you need to use a standard RBD functionality. And all of this is already built in here in the RBD bullet solver SOP, which is the one we will use the most. Okay, so this is just an overview, so that you have the basics. And what you will see with the RBD setup is it sounds easy and it looks easy in the beginning with something that simple, but trust me, it will become very complex because there's so many things that you need to consider. Just mark my words, you will see that. Okay, so I hope this is helpful to get some kind of idea where we came from. This was before Houdini 18, and it's much easier now with a new DOPs and SOPs concept. All right, thanks very much, and see you in a later video.